theory in democracy. Also, we talk about the components and we talk about the migration and how the migration and the death or fertility can affect or changes of demography or population changes. Where we talk about in fertility, we talk about it is the number of children a woman can produce. And then when we talk about mortality or death rate, it is the number of people who dies or number of deaths in a particular population. And again, also we say that fertility can add to the population, and then deaths can decrease. And in migration, we say that migration can either add or it can subtract from a population. I think these are the few things I can talk about this model.
Okay, thank you. That is okay. But I would also wish to interest you, since you're the only one here. I would want to interest you so that you can further understand why this module is very important. One, especially if you want to understand health related issues or the health dynamics in the society. This is actually the module because you understand that in human capital development, the main key departments we look at is health and education. And I can assure you that if you understood your population, which in this case is demography, if you demographically studied your population, you would solve, if not all, three-quarters of your health issues. And demography and health is one of the interesting topics, but also modules. Away from what we share here, I would want, as students or as scholars of demography, that you guys interest yourselves in literature. There are a lot of books that you could actually read, and you'll be able to understand the different concepts of demography and health. Let's continue to wait, or we can start since it is a recorded session. Possibly the other guys will join us in a bit. Ivan, I don't know what you.
Yes, good evening.
Good evening to you.
Yes, good evening.
Yeah, I think it's only one student who has connected, and I don't know whether others will join in later.
So since we don't know that whether others will join, what is your advice? Can we just start and then, if there are those who shall be joining, we shall they will join, and those who won't, we can just they will do the recording.
Yeah, you can continue. As like yesterday, others were joined when you already started. So you can do the same. You can continue as I'm recording.
All right. As usual, I would want to first share a brief of what we discussed yesterday. And what is key that I would want you to note is the systematic way we've been flowing with this particular module. From our introduction to demography, we were able to look at the key concepts in demography and health, and we were able to look at what demography is. We were able to look at what population size, what composition of the population, but what distribution also of the population is. And we were able to look at some of the five key aspects that demography covers as a whole. And we also were able to understand how population transitions have occurred in the past. And that introduced us just into the history of demography. And throughout the history, we were able to understand some of the key theories that demography has, and some of the basis on which demography has been made on. Then we were able to understand the three concepts in demography. Mainly, we were able to understand fertility, we were able to understand mortality, and we were able to understand migration, which we did yesterday. But also, the previous day, when we were discussing the composition in terms of what the population may be of, we looked at sex and age, and we were able to do calculation of how you can determine the sex composition using different formulas that we shared, including the sex ratio, including the masculinity proportion, and including the deficit of males. And then when we dived in yesterday, we were able to look at the different the different theories that are helpful in determining how the population dynamics occurring today are. We were able to look at the we were able to Yes, we were able to look at the Malthusian theory. We were also able to look at the optimum theory of population. We were able to look at the demographic transition. And at the end, we were able to look at data, how we could be able to sources of demographic data and demographic health data. We were able to look at direct and indirect means of obtaining that data, in which in our direct means we were able to look at how a census is carried and how it helps us to gather a lot of demographic information that we could help to understand more of our population's dynamics. Then we were also able to look at vital statistics, including birth registrations, death registrations, and how these are very key in trying to determine how the population growth can occur in terms of how many deaths and how many births can occur, and then how they will impact on your population growth. Then we looked at the indirect methods, and we were able to look at the sister method, where you're interviewing a relative or you're interviewing someone else to give you information on death. So then, because you cannot interview an individual who has died, it is only through autopsy or what we call verbal autopsy that you can get such information. So today I want us to interest ourselves, having given you all that background. I think Matut has had, having given you all that background from where we started up to today. I want to give you a topic that or a lecture today that is going to help you in analyzing. If you're able to know how we do data collection on health, on demographic health data, then it would be useless if you do not understand how this data can be analyzed. So today, just as I start to share my screen, I would want us to look at what I would call uh, let me just, oh, it is not yet open, but what I would call a data analysis. And in our data analysis, I would want us to go into analyzing these three concepts of fertility, mortality, and migration. Because you will understand, as I explained yesterday, that fertility or the number of births in a society affect your population growth. And if you're a public health expert, you should be able to understand the relationship between population and fertility, because then you will be able to understand that if there are more births in your, if people are giving more birth in terms of fertility, then you will be able to understand what needs the population has. So let me just share a screen with you as I start this presentation, but I would want you to have a very critical uh, thought, but also a very deep understanding of data analysis, which can be very key for you in your different spheres of life. So the analysis of demographic data. And in this case, we are going to look at those three main concepts of fertility, mortality, and migration, as I have said. So, the analysis of demographic data is a standard array of techniques and measures, stroke forms that are the basis of all demographic analysis. The most common of these are briefly described here, but further detail is supplied in a number of textbooks. So I'm giving you these textbooks as a reference so that you will be able to look at these tests. For example, Preston and the other authors of 2001, then Rowland of 2003. But there's also the materials and methods of demography by Siegel and Swanson. And it is a very good book for analysis or analytics of demographic data. So analysis involves not just the application of a particular technique, but also decisions about what units of analysis to use and how to group them. So a major distinction here is between period and cohort analysis. Uh, just to take you into what a cohort is, this is a type of grouping, or in simple terms, it is a grouping of individuals who share a certain characteristics, and they are with similar behavior. That is why you will be able to see age groups in a cohort analysis, and you will be able to see the ages 1 to 5. Sometimes it is 0 to 5. So that is what they call a cohort analysis. And the period is most times the time that varies between weeks, days, sometimes months, like that, and yearly. So period analysis deals with events of a particular time. For example, we want to look at mortality rates from 2005 to 2010, while cohort analysis follows the experience of individuals through time. So you should be able to differentiate between these two, cohort and time period. Cohort, in this sense, are defined as groups of people who have experienced the same significant events at the same time. Thus, birth cohorts comprise people born in a particular year or group of years, and marriage cohorts, those marrying at a particular time. You see, these are people who are marrying at a particular time, so they are sharing a particular experience or character or characteristic. So children that are born in a specific year, per se 1999, would be the cohort of 1999. I'm giving emphasis to emphasize cohort and period, because in data analysis, especially demographic data analysis, you will be able to see these words frequently. So it is key that you pay attention to them in here. Cohort and period are two of the dimensions which place persons in time. The third is age. So the duration effects such as duration of marriage, proximity to death, or length of exposure to a particular pathogen may also be important. Now, this is where the health part comes in. What are some of the dimensions that place persons in time? What is your duration of marriage? What is your proximity in terms of how quick or how immediately are you going to die? For example, for the calculated bit of what has been done, for example, the other day when we were looking at the, 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 the age life expectancy of Sudan, possibly if someone clocked about 59, then you should be having a proximity to death through what we call the average life expectancy that is done in what we call the life tables. So it is very key that you understand uh, the cohort and period analysis that I'm just describing here. Cohort effects may be substantial and unless allowed for may mask relationships between age and various risks. The differences in the smoking behavior of cohorts, for example, have a major effect on the relationship between age and smoking related diseases observed at different periods. Now, if you wanted to use a cohort uh, to understand the effect between age and people who are smoking, you would using a cohort analysis would have an effect on trying to understand which age is specific, because you would have clamped them there and you will not be able to, because people you're not these people in that age group, they do not share an attribute of smoking. So what will then happen is that if you use the cohort analysis, it would hide in what it is showing you here. It may mask relationship between age and various risks. So if you had an age group of 1 to 4 and you wanted to understand how these ages relate with smoking diseases, it would be hard for you to understand that people who are 1 year old have the same risk. People who are 2 years old have the same risk. So that is where they are trying to identify for you a gap that may result as a result of clamping ages in a cohort form. So I just want us to go direct. After understanding what a cohort is, I want us to go and understand how do you measure fertility. This is very key. Now, decisions about whether to use individuals, families, households, or geographical area as units of analysis are often constrained by availability. Until relatively recent, most census data were only available as aggregate tabulation, but individual level information is increasingly becoming available. So this statement in here is just reflecting back into how we have challenges in our societies on getting individual data. Now, until today or until of recent, data from censuses was tabulated or was put in form of a table, or it was aggregated in terms of you cannot get an individual as what, as himself. If you wanted to use, for example, me in a census to understand my fertility, that information would not be possible. The information you could only get would be information that is general. So you would have data for general purposes. So and then if you want to do analysis, you cannot do individual level analysis if you have data for a geographical area. For example, you have data for this province. For example, you have data for this household. So it would make analysis of individual data quite a very hard bit. However, other innovations include the development of samples, including linked sensors, vital statistics, vital registration, and some cases health service data such as longitudinal studies that have been done, meaning that they have been using secondary data. That has been collected is analyzed. However, they have also been doing sample surveys in order to do this measurement of fertility. So, this is the continuation of fertility. But what do you understand of fertility? Fertility means the childbearing performance of a woman, couple, or a population. Generally, only live births are included, whereas the term fecundity, by contrast, is used to refer to the physiological capability of producing a live bone. These are key definitions that you need to understand in the concept of fertility. So fertility, you're looking at childbearing performance of a woman, whereas in fecundity, you're trying to look physiologically whether this woman is able to produce a living child. So a woman that does not have the physiological capability to produce a live baby is unfecund, or it is the common word you see people using, that this person is unfecund. Now, a rough idea of fertility may be gained from using census or survey to calculate child-woman ratio. So the ratio of 0 to 4 years old to women aged 15 to 19. However, the survival of infants and their mothers and the age structure of female populations affect ratios. So they are generally only used if no other data is available. So you could do a child-woman ratio, but there are always challenges with data to do this measurement of ratio. So most times this particular measurement is only used if there is no data, or if data is scarce. So the simplest measure for fertility, excuse me, the simplest data for fertility that is always used is what we call the crude birth rate. Now, what is the crude birth rate? This is the number of births in a particular year per 1,000 population. As the denominator of this includes those not at risk of giving birth, women outside reproductive age groups, and men. It is rarely a ratio rather than a rate. So I'm going to show you in the lower slides how these calculations can be done. But I'm trying to show you here that measurement of fertility. Now you can decide to localize it to your health facility, or to your school population, or to your community population. So what you will do, if you wanted to understand the number of births in a particular year per 1,000 population, that out of your 1,000 women of reproductive age, how many births will they have? You would be able to use this thing called the crude birth rate. However, as your denominator, you cannot use men or women that are 15 years and below, or women that you expect cannot produce. Women that are above 49, or by research are below 15. These are women outside reproductive health age, reproductive age. And men generally are not part of measuring fertility ratio in a community. So this is actually a rate a ratio but not a rate. Crude birth rates are influenced by age structure of the population, but less seriously so than crude death rates. So in 2005 to 2010, crude birth rates ranged from less than 10%, 10 per a thousand in parts of Europe to nearly 50 per thousand in the highest fertility countries of Saharan Africa. So in Europe, uh, out of 1,000 women, only 10 would be or would have okay would produce, and then yet if you compare it to Africa, out of every 1,000 women, we would have 50 births. So that is extremely very high figure. So slightly more sophisticated is the general ratio. You need to look at the general fertility ratio as another measure of fertility. So let me just insert here for you a slide and show you what I was trying to show you in terms of measuring. Uh, if you want to measure, crude uh, birth rate. So I was going to say, as I said, that this crude birth rate will equal to, here, that you're looking at birth, number of birth in a particular year over total women of reproductive age. Just as I was telling you here, that you're looking at the number of births in a particular year, and you will multiply this, because you want to look at say you want to look at, this would be times 1,000. So for just illustration purposes, if you wanted to look at if your births in that year were about 100 births, these are live, these are live births, these are live births, and then if the total number of women of reproductive age, let's say there were 2,000 women aged 15 to 49, because this is women of reproductive age, then you would be able to multiply this and say 100 divided by 2,000 to give you, if you use the calculator, just I'm trying to give you a practical explanation of how you could come up with this. It may not necessarily be a particular, it may not be the entire country, but if you worked in a health facility, you will realize that this ratio here can help you plan for how many children you can see in a month. So this figure would be 100 out of 1,000. So you would say that you have 1,000, 100 bucks per 1,000 population. So knowing that from our definition here, we said the number of births in a particular year. So you'd be able to understand that out of every 1,000 women, you had 100 births. And this is very key in planning. It is telling you that slightly a more complicated uh, measurement is called the general fertility ratio. These are births per 100 women of reproductive age, where data, okay, generally defined as this. These 15 to 49 is what we call the reproductive age. But for some people, of course, it applies up to the age 44. Where here data allow age-specific rates are used. So births per 1,000 women of a particular age are preferred. So the general fertility ratio uh, is actually using what they call age groups. So just to illustrate, we're talking about the age group 1 to 4, but there is also an age group of 15 to 19. So these are age groups that if you went to data, to extract data from any demographic book or demographic health survey, you would be able to see what they call age group and age cohorts. These are frequently summarized using the total fertility rate. So this general fertility rate is most times it is just summarized instead of people doing per age, especially you do 15 to 19, 20 to 24 in those age groups. What happens is that they now summarize all this total fertility rate. uh, they now summarize all the general fertility ratio into total fertility rate. Whereas is usually the case, period data are used to calculate this. It indicates how many children women in a hypothetical cohort would have if they experienced current age-specific fertility rates throughout their reproductive life. So what happens is that throughout their reproductive ages, every woman experiences an age-specific fertility rate. So when you clock the age 15, there is a specific fertility rate that you have. As you advance in age, your fertility rates keep declining. That is why a woman as the woman clocks to her 49, the chances of her becoming fertile are lowering. Now, those are the age specific fertility rates that this particular total fertility rate uh, applies in order to understand how many children a woman can bear when they are experiencing those age specific fertility rates. This measure is sometimes noted as total period fertility rate. This is a very interesting measure, and it is a measure that is used worldwide. In low mortality populations, a total fertility rate of 2.1 is taken to indicate replacement level fertility as under this regime. A cohort of women would be succeeded by a cohort of daughters of the same size. What does that statement mean? That in countries death where deaths are very slow or very low, if the total fertility rate of women in that country was 2, what we see as 2.1, it would mean that the replacement level would be succeeded by a cohort of daughters of the same size. So, if there were 100 women, and their total fertility rate was 2 meaning that they can produce 2 children as their total fertility rate, then it would take the same 1,000 girls or daughters of these women to replace what now we're calling the replacement level. So after some allowance of mortality, And the fact that 105 and 106 boys are born for every 100 girls. One difficulty with the TFR is that it is affected by changes in the tempo as well as quantum of childbearing. So what happens is that because this is not a constant rate, although the the measurement states that you you have a specific fertility rate that you're subjected to, sometimes these vary. So it becomes a little hard for us to assume that this is the exact TFR of that. So so later here it is telling you that if women start delaying their fertility but catch up later, there will be a divergence between cohort and period measures, as the latter will be based partly on the behavior of early cohorts whose timing of birth was different. So what happens is that if a woman delayed birth, for example, the assumption in a cohort analysis is that for every cohort or age group that starts giving birth, as a demographer, you would assume that this particular age group will have their next birth in 3 years, because we take the entire years of child growth. So what happens is that when women begin giving birth late, and then as a compensation measure, start giving uh, catch up birth. For example, every other year a woman conceives, then it distorts the measurement that was used or applied to measure uh, total fertility rate. Similarly, for women who begin earlier, then their total fertility will rise. Even if eventually their family sizes remain unchanged, then it means that their period measures are much more volatile than cohort ones. So what is more important sometimes is to do single age analysis. So instead of clumping individuals into what we would call these cohorts, it is sometimes very better for you to use what we call single years. So you would be using 15, 16, 17, 18, rather than saying the age is 15 to 19, because of the challenges in there of cohort analysis that I have discussed. Yes, I hope we are proceeding well. If there are any questions, you could raise them as well. Uh, so let me just give you a summary of the definitions. As we stated, that the fertility is the childbearing performance of individuals, fecundity is the physiological capability of producing, but there is also another important term that is called parity. This is the number of children previously born alive to a woman or to a couple. So what happens is that uh, for example, for those that have had a touch with what we call the what we call the antenatal care register, you would be able to see that they are asking for the parity of a pregnant mother. So what happens is that parity, therefore, is trying to understand the number of children that were previously born alive by that woman. And then there's what we call nulparous women, are those who have not born any children. Why is this very important? If you went and did a survey or a study and you understood the parity of your society, meaning in a particular population, how many women have had children born alive and what is the number of those children, you will be able to assess the risk of maternal deaths or maternal complications if the parity of the population is high. However, in a population that is nulliparous, meaning a population that has not given birth, you would try to understand that in the next phase, you would have either a population explosion or you would be starting to prepare for new birth, as assuming that there would be less risk regarding complications to pregnancy. So these are some of the key measures. This is again another measure that is very key in trying to understand fertility. So remember, in our earlier calculation here, a crude birth rate for a particular population. So here, the other side, we are trying to look at we were trying to look at women of reproductive age. Now here we are trying to express and look at the entire population. The entire population. So in this case, we're saying that the ratio of births in a year to the average population in the same year expressed per 1,000. So I'm just giving you a summary of the previous the previous equations that we said we can use for calculating crude birth rate. Another rate is the general fertility rate, where we are looking at births to women aged 15 to 49 in a year over 1,000 women who are aged in this same cohort. But as I earlier said, that this one applies to age specific. So just in here, you would start to apply. Let me just do for you here some minor calculation here. So then, what we were trying to discuss as age specific, we're meaning that, for example, for the ages 15 to 19, for the ages 20 to 24, for the ages 25 to 29, for the ages 30 to the age 34, and so forth and so forth. So for you, if you're calculating general fertility rate, you're calculating births to these age specific women, meaning you're getting women who were aged between 15 to 19 who gave birth. Then you divide this by the total population of women in the age specific aspects, meaning these age groups would be here, like that. Yes. Do you get it? Do you get what I'm trying to explain, Matut? Do you get? Or you would want a clarification? You're open to discussing.
Yeah, I've got this.
You've got,
Yeah.
Okay. So, what we call the total period or the total fertility rate is the sum of age specific, as I've explained. But you can be able to see here that the TFR indicates how many children a woman will produce throughout her reproductive life. She had children at an age specific prevalent specified year. So this is just a description of what I wanted to show you. If you're calculating TFR, so where F is the age specific fertility rate at age X. So at this thing here, you're trying to calculate the births a woman had from her ages X, which is 15, to about 49, which is just as similar to what I have been explaining in this slide here. Here. So what is key is, you remember earlier on, I had said that there is also what they call parity. If you were to see this slide that I was just showing you earlier on, and I was telling you parity is the number of live children that were previously born by a woman. So we're trying to tell you what parity progression ratio is. The parity progression ratio is the probability of a woman of parity X progressing to parity X plus 1. So for a woman whose parity was 3, the probability of progressing to parity 4 is 3 plus 1. So your probability of progressing to the next parity. So if they asked you a question to estimate the probability of of individuals of a parity 1, 2, 3, 4, and 5, you should be able to understand that the probability of a woman who has a parity 1, the probability will be 1 plus 1 to give you 2, like that. So that is the parity progression ratio that would be. So another key measure or measurement of fertility is what we call the gross reproductive reproduction rate. What is the gross reproduction rate? This is the sum of age-specific female fertility rates, meaning we are looking at births of daughters. Now, gross reproduction rate helps you to understand how replaceable your population will be. So what happens is that the sum of age-specific female fertility rates, you're only looking at birth of girls for all reproductive age groups for a particular period, conventionally expressed per woman, and the gross reproduction rate indicates how many daughters a woman would have if throughout her reproductive life she had children at the age-specific rates prevalent in the specific year of period. So what happens is that we are subjecting mathematically, this is now a statistical package, where we are mathematically subjecting these girls, I mean these women, to what we call age-specific rates. So this gross reproduction rate is used to determine how many daughters a woman would have in her entire reproductive life. Now, the gross reproductive rate can be calculated either by summing female age-specific fertility rates relating to births of daughters rather than all births, meaning you add all daughters that have been born by women of that particular reproductive health age, or you get the total fertility rate, which you see that we calculated here above, the total fertility rate just here by getting all the number of births and subjecting it to all the number of of the population, the media population of that particular population. So you would be able to see that the gross reproductive rate would equals to that total fertility rate times the proportion of female birth. So determining female birth would be that you're multiplying all children that are born female. I hope that is clear. If you want to ask a question, you're free to do so. Net reproduction rate is the is also another measure, and for it, it is an average number of daughters that would be born according to specified rates of mortality of bearing daughters by a female subject through life to these rates. Now, the net reproduction rate employs the same fertility data as the, the, the gross reproductive rate, but also takes into account the effects of mortality. So the advantage with the net reproductive rate, it is that for it takes effect of children that may die, or daughters that may die throughout the reproductive age, unlike gross that only looks at all live birth. So the net reproductive rate of 1.0 indicates that a population's fertility and mortality levels would result in exact replacement of mothers by their daughters. So if you did any calculation and your net reproductive rate was 1, it would mean that for that particular population that you've subjected to calculate the net reproductive rate, it would mean need the exact number of those daughters, or the exact number of those mothers uh, to, 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 to replace, of those daughters to replace their mothers. For example, if you subjected it to, if we had our TFR, for example, Uganda's TFR is about 6.1, no, 5.1, and its proportion of female birth. We could just look at, because we want to understand this better. We just want to check here Uganda's proportion of females, and if it can give us a rate. So it is telling you it is about 50, but what is the ratio? Is 100 males? No, that is the world population. But let us look at ratio of females in Uganda, and if we got about 23 million, about 23 million. So if you got about 23 million, then we subjected it to women of reproductive age, we could possibly get about the proportion cannot, if because proportion we're looking at proportion is not a rate, so it may not be a very huge figure. So you would probably be looking at maybe 0.12. So that will be the proportion of women of reproductive age, meaning from women, the proportion of female births, maybe if there were 1,000 births in the country, and then we said out of those 1,000 births, you got 50 female, 50 female divided by 1,000, and then you multiplied it to give you a ratio. Maybe if we had here 0.5, then 5.1, which is Uganda's total fertility rate, and we multiplied it by 0.5, we could have our answer would be 2.55. So then, to interpret this, you would realize that it will take twice the number of mothers who produced these daughters. So meaning that you would, if there were 1,000 mothers that produced these daughters, it will take 2,000 daughters to replace this number. That is what it is roughly meaning that it is easily replaceable, that Uganda can easily replace the mothers that have given birth to daughters, because their proportion of female births is more than the proportion of male births. So in any day where you see there are more female being given birth to than males, you understand that the society's uh, replication rate or the replacement rate is high. So that is fertility, and those are the measurements of fertility. Now we want to look at the measurements of mortality just in a bit. As for fertility, the simplest measures are these, and these strongly influenced by age structure. Although life expectancy at birth in the more developed regions of the world, uh, the most important measure for just like for birth rates in mortality is also the crude death rate. And let me just skip for you those slides, because they are virtually explaining what I could explain in these 3 paragraphs. If you read this measurement, it would say that age-specific death rates are calculated using the number of deaths at age X between the ages X and X plus N in a particular year as the numerator, and the mid-year population of the same age as the denominator. The rate is conventionally expressed per 1,000 or per 100,000 population. The median population is used as a measure of average population at risk, on the assumption that deaths are evenly distributed throughout the year. For some age groups, infant mortality rates were very high in some of the parts of Europe. We're just trying to use Europe here as a case study, but just to bring you back to book. So these are the key measures you can use if you wanted to understand the death pattern in your society. So having understood the birth or the fertility pattern, it is only important that you also understand the death patterns in your society. So the crude death rate is the ratio of death in a year to the average population in that same year. So it is expressed in that per 1,000, meaning we get the number of deaths in the whole year over the media population times 1,000. Then there's also what we call the age-specific mortality rate, which is the number of deaths to persons aged X. Meaning if you were aged X, the next if X was 15, the next person aged would be 16. So we're trying to get the number of deaths in all these years, which we put in a statistical statement as X to X plus N. So we're trying to look at the age 15 plus 1 to make it 16, 17, 18, 19. Then we subject it to all those persons who are aged at that same thing. So we're getting the number of deaths of people in all those age groups divided by the population of the people who are aged like that. So just the illustration is here. Age-specific mortality rate, then we're saying deaths to persons aged X divided by media population of persons aged X. Now, you may not need to look at these measures in isolation. Now, in a practical bit, you could virtually go to a health facility and understand what are their key causes of death, or which age group is dying very more in a particular health facility, or which particular uh, population or society is having rare death. So you would subject using this would now become cause age specific mortality rate, where you would say deaths of children aged 5 and below who died from malnutrition divided by the total number of children aged under 5 who were at risk. Meaning, at risk, we're trying to look at either a geographical boundary of a province, of a sub-county, or just any community thing. So we are trying to show you the measures, not that you just specify yourself in trying to look at age-specific mortality rate. You should be able to have a drive to understand which ages are suffering more mortality in your community. That is why, that is the essence of why I have introduced these particular measures, or what I call the analysis of demographic health data. So there is what we call the standardized mortality ratio. So the ratio of observed to expected deaths in a study population. What we call standardized is that you're doing a comparison, and expected deaths are calculated by applying a set of standard age-specific mortality rates. So standardization is only useful for comparison, and it definitely has no big meaning. But what happens is that if you picked death, particular death, expect that you've observed in another population for per se. If you said you looked at the population of Europe, then and you would observe the patterns of Europe, and you would be able to apply your own and use this and use what they call the standardized mortality ratio by applying those standard age specific rates of that population of Europe to your own population. Then you would be able to understand that this is your age specific death rate. So what happens in standardization is that you're just trying to compare that if the death specific rates of that country were applied to yours, you would realize these changes. However, if we, for example, a developed country like the UK, where the death or the age specific mortality rates are very low in terms of their standard. For example, for them, they would expect that at the age of 50, someone might still, their specific age mortality rate could still be about 0.7, because for them, that would still be a higher age. Whereas for us, by the time you're closing 50, you're already on 0.2, 0.3. So if you standardized and used their specific rates to yours, you will realize that no one can clock the age 59, or the number that has clocked the age 59 would be very low. That is what that means. So another important measure that you can actually use, that is being used commonly, is what we call the infant mortality rate. An infant is an individual that is aged below 1 year, or a person who has not celebrated their first birthday. And this infant mortality rate is calculated. Yes, someone has a question.
Fuani
Oh,
Shuma Nando.
you have not been seeing my screen, eh? Have you been seeing this screen? Oh, someone has unmuted. Someone has a question? No, eh? Let us proceed.
I think we can continue.
You're seeing this screen, eh?
Yeah, yeah, we're saying.
Yes. So the infant mortality rate, we're looking at number of born live births below 1 year. So if we are calculating mortality, we are roughly looking at the number of young people or infants that die before their first birthday. So how do we calculate this? We go and get the number of deaths of children below 1 year and subject it to all number of children that were born in that particular period, and we multiply it by 1,000. Sometimes decomposed into neonatal mortality rates, deaths of live-born infants during the first 4 weeks, and post-neonatal mortality rate. This infant mortality rate sometimes is divided into what they call the neonatal rate, of meaning people who have died in their first 4 weeks of birth, and then also what they call the post-neonatal mortality of infants that have died between 4 months, 4 weeks, and 52 weeks, which is roughly a year there. The perinatal mortality rate measures late fetal death, which we call stillbirth, and early neonatal death relative to live births. So stillbirths, when we're talking stillbirth, we are referring to deaths of fetus of 28 or more weeks. So the perinatal mortality rate measures the late fetal deaths and early neonatal deaths relative to live birth. So for those who for the babies or the fetuses, a fetus is something that is not yet is not yet born. So when we're talking about stillbirth, or what here we're trying to look at when we're trying to make what we call the perinatal. Perinatal is talking about stillbirth and neonatal deaths. And neonatal deaths, we are saying they are death of children in the first 4 weeks of life. So these 4 weeks vis-a-vis fetuses that were 20 weeks in gestation, they are what we call stillbirth. So in this stillbirth, most times you see a mother gives birth to a fetus that has died. These are stillbirth, but also children that live for 4 weeks only and then die are part of what we call perinatal mortality. Uh, However, an earlier threshold of 24 weeks is now more generally used. So the standards of measuring what is a stillbirth and which one have been reduced to about 24 weeks. So a woman who gave birth to a fetus that has died, uh, whose gestation period was about 24, would be considered stillbirth. So we want to understand how to measure perinatal death. So this is just to understand what is perinatal mortality rate. So we are taking stillbirths plus all deaths under 1 week over still live birth, and then we multiply by 1,000, and we shall be able to get what we call the perinatal mortality rate. That is that for what measurement of mortality is. And equally, the same way you can be able to apply causes of of diseases to death is the same way you can be able to understand and socially go and relate why some of these mothers have stillbirth. Possibly you can be able to understand, uh, for example, by using antenatal care attendance as a measure. For example, you could subject and say uh, number of women that were able to have 8 or 4 antenatal visits uh, vis-a-vis all attended all total attendance. Then you will be able to further understand that how many stillbirths occurred among women who attended all the 8 visits vis-a-vis those who did not attend. These are some of the reasons we're giving you these tips so that you will be able to have a practical feel of this. So here, how do we measure migration? Now, unlike the other measures, migration is quite a very difficult concept for many of the statisticians and demographers to accept, to measure. So migration represents particular difficulties. The classical definition of internal migration is a permanent or semi-permanent move across an administrative boundary, which means that the extent of migration recorded depends on the size of administrative areas. For example, in a country divided into small areas, a move over 5 kilometers will count as migration, which will not be the case for countries that are divided into large areas. Hence, international comparison of internal migration rate is potentially misleading. So, why it is very difficult for you to have measurements on what we call migration, yet it affects a health component, is that unlike some countries that may have um, what they call sub-county, parish, village, or a province, or a district, they may define migration as moving from one village to another. The village may just be here or over there, but also a country that is large, has larger boundaries would consider moving from one district to another or from one province to another province as what they call migration. But it is a little difficult to comprehend what comparison can be done in internal migration. So even the distinction between international and internal migration may be problematic if the boundaries are contesting or changing. For countries that are having international boundary problems, this may be a hard issue to measure. The temporal dimension to migration presents further difficulties. Now, what constitutes permanent or semi-permanent, and how should groups such as seasonal migrants be treated makes it very hard for migration data to be analyzed and measured. So what happens is that if they say this one is permanent and semi-permanent, they need the classification of the period of permanency is a little hard. But also trying to understand seasonal migrants makes it very more difficult to do measurement of migration. For example, for those who are cattle rearing communities, it is a little very hard for you to measure their migration status, because they will move from you after 1 week. They will move in search of food for their animals. Now, moves of this kind are recorded. Moreover, this is the information required by local administration. Now, for research purpose, analysis of all moves may often be referred. So, So because of these unnecessary moves, it is quite difficult. However, in any case that an individual is crossing a boundary through an official or designated area, these movements are always recorded. Some countries have registration systems in which change of addresses are recorded. So anytime someone wants to change an address, they are recorded. So more commonly, censuses are used to find out about migration. So the questions on usual address 1 or 5 years ago allow the proportion of movers in the population to be measured, except for those aged less than 1 or 5. This data also allows the inflows and outflows between pairs of areas to be measured. So what happens is that it is only a census that most times gives especially low developing countries uh, an idea of how countries or how their migration is. One, because uh, when you subject your population into a census, you will be able to understand how many births and deaths have occurred. So for all those births and deaths that have occurred, when you subtracted, you'll be able to you'll be able to have the data error as a result of migration. So if you had 2,000 births in a period of 1 year, or in the entire period of census, if you had 2,000 births and then 1,000 of these people died, you should be ideally having 1,000 people left. But if you realize that instead of having 1,000 people, you have 800 people, and then it should be able to give you an idea that the remaining change could be as a result of migration, that some people have left that particular area. So in the absence of direct census data, estimates of migration can be made indirectly using the balancing equation referred to in the which I think we discussed, was it yesterday, where you were able to just let me insert for you here a slide so that I could show you. So for you to estimate your population X, you should be able to have your previous population, which is your base population. You add plus in brackets minus births minus death in brackets plus immigration minus emigration. So this would give you what we call natural change, and this other one would give you your migration. So for you to make an estimation, if your base population was like I said 2,000 individuals, if you added this and you had maybe 5,500 birth minus death is always lower than birth unless it is a pandemic. And then you had those deaths, then you should be able to add, and then you should be able to understand that here you're having about 300 people left. So you would have 2,300 people left. However, you should be able to understand that where are the other 300 people. So if you subjected this and realized that for you your counting in was 2,300 or maybe 2,100 here, then you would be able to question where the remaining 200 people are. So you should be able, you counted here that you have 2,400 people here. So you should be able to say that it is possible that the 100 people are from this migration, that they either left or they came in the country. So that is how we could simply do estimation of, of your migration. So just there we're saying that differences in the absence of direct census data, estimates of migration can be made indirectly using the balancing equation, which I have discussed there. Differences in the size of a population at 2 points in time not accounted for by natural change. So these 2 points of time is the current point you're saying vis-a-vis your base, which I just showed. So if your px was 2,400 and your base is 2,300, and yet you've subtracted, you have added your birth and subtracted the death, you should be able to understand that possibly 100 is a data error or it is part of migration, which this statement is showing in here. So if vital registration data is available, then both birth and death can be taken into account in measuring. So if they are lacking, then the survival of groups enumerated in the first pair of a census must be estimated from a life table, and the number of expected survivors compared with the number enumerated in the second census. Obviously, aging must be allowed for. So the number of 20 to 29 years in the first census will be compared with 30 to 39 years old 10 years later. So these methods only allow estimation of net migration. So you will be subjecting that people who were aged 20 to 29, their number should be about 30 to 39. Okay, should be, they say, because after 10 years, they could be 30 to 39 years. So they were 20 to 29 years, and now after 10 years, they should be 30 to 39. So if deaths are applied, then you should be able to understand where and estimate where particularly some of these people have moved. So this method only allows estimation of net migration. So in migration, how many people have come out, how many have gone out, in that case, may be a very hard bit. So friends and colleagues, that is, I think we're at 8:30. That is how far we can go. Hopefully, we've covered a little much of the module, and we could conclude in the subsequent lecture. So just from that point, I am making conclusive remarks. Therefore, if you have any question, you could raise them. However, if you do not have, I would want to hand over back to Isaac.
Yes.
Yes, you have a question, please.
Yeah, I think mine is just a request. Are you getting me?
Yes, I am.
Yeah, I think my request is that if possible, when you are sharing the lecture notes, I think you can look for maybe some textbooks, if possible, with some calculation, so that we can read through them and then we can know the calculation parts.
Okay, that is okay.
Yeah.
Can you be able to do that over the weekend?
Okay. Thank you.
So are there any more questions? If not, Ivan, I have made my concluding remarks, so I hand over back to you.
Yes, thank you very much, Mr. Aloysius, and thank you for this today's lectures. So we shall meet tomorrow again at the same time, and I would wish to end the meeting right now. Thank you.
All right. Have a
Have,
good night.
have
Good
good
night.
night.
Good night too.